Hello students, welcome to today's session of chemistry. As you all know, we have started studying fifth lesson of your syllabus, that is electrochemistry. We will just revise some basic points we learned in previous two sessions. First and most important thing is about this branch of chemistry, which is concerned with interconversion of two types of energies, chemical and electrical. And redox reactions are the basis for both types of convergence. And these reactions are carried out in a device called electrochemical cell. And this branch of chemistry deals with design and operation of such cells. We also learn about electric conduction. Electric conduction, in short, we can say it is a charge transfer or flow of electricity. And this charge transfer takes place through some substances called conductors. There are two types of conductors that also we learn, that is metallic conductors and electrolytic or ionic conductors. Electrical conduction, if it takes place through metals by direct flow of electrons, then it is metallic conduction. And if the conduction through electrolytic conductors, which involves transfer of matter from one part of the conductor to the other, is called electrolytic conduction, where ions are involved, and these ions are produced by electrolytes. Electrolytes are of three types, or three examples we have taken, that is acids, bases, and salts are the electrolytes, and those are of two types: strong electrolytes and weak electrolytes. The electrolytes which almost completely dissociate in aqueous solutions are strong electrolytes, while the one which dissociate to a very small extent in aqueous solutions are called weak electrolytes. Those also we learn. We also learned about electrical conductance of solution, in which we learned Ohm's law. And that law tells that R is equal to V upon I, where R is resistance and it is equal to potential difference V divided by electric current I. And by using resistance, we found out another equation, and that is for conduction. And electrical conductance G is reciprocal of resistance, that is G equal to 1 upon R. And by using both the equations and equating them by taking proportionality constants, finally we got relation between conductivity and resistivity. And we found out that K is equal to 1 upon rho. That means conductivity is also reciprocal of resistivity. Now, in today's session, we are going to study about molar conductivity, and it is represented by lambda. This is the sign, that is inverted V, but it is capital lambda. So, molar conductivity has been denoted by lambda. Now, about molar conductivity. Why it is needed? The electrolytic conductivity is not suitable for comparing conductivities of different solutions. That means if we want to compare few samples and find out the conductivity of those, then electrolytic conductivity is not suitable. And for that, what is the reason behind it? The conductivity of a solution, as you know, it depends on the number of ions present in unit volume of solution. Unit volume of solution, that means volume, it is measured in cubic centimeter or cubic meter. That means 1 cubic centimeter and 1 cubic meter. If it is kept constant, then conductivity depends on the number of ions present in that volume of solution. And the solution of higher concentration contains more ions in the same volume, and hence it exhibits higher conductivity than the solution of lower concentration because it has less number of ions and it exhibits lesser conductivity. Hence, how can we compare such solutions? So, what must be kept constant? That means if you want to compare conductivities of different solutions, the most important thing is they must have the same concentration. Then only we can compare the conductivities of them. And for that, a new concept came, and that is molar conductivity, which is given by German physicist F.W.G. Kohlrausch in 1880. He introduced this term molar conductivity, which is denoted by lambda, and he has given one equation for that. The molar conductivity of an electrolytic solution is the electrolytic conductivity K divided by its molar concentration. That means to find out the molar conductivity, we have to divide electrolytic conductivity K by C, that is molar concentration. Now we got the equation lambda is equal to conductivity K divided by concentration C. Then what will be the unit of lambda? Let us find it out. Now, in SI unit, K conductivity, we know its unit is Siemens per meter. And that of concentration always has a unit moles per cubic meter in SI unit. Hence, SI unit of lambda will be, if we substitute the value of K and C or units of K and C, we will get it Siemens meter square into per mole. So, SI unit of lambda will be Siemens meter square per mole. And if common units employed, then SI unit will be meter, but common unit is centimeter. And Siemens in common unit we use omega. So common unit will be per omega, that is Siemens. Instead of meter square, we are going to use cm square, and moles will remain as it is. Hence, common unit will be per omega cm square per mole. Understood? Per omega cm square per mole. So this is the unit of lambda, that is molar conductivity. Now let us learn about significance of molar conductivity. What is significance? That is importance. What is the importance of lambda? So first and most important thing to understand the significance of lambda, take or consider volume of a solution containing 1 mole of dissolved electrolyte. You learned about mole concept last year. Mole concept, which contains Avogadro's number of atoms, ions, or molecules, the one which occupies 22.4 cubic decimeter of volume. Everything. Mole is a versatile concept, versatile unit of measurement, we say. So it tells us about mass, it tells us about number, as well as it tells us about volume. If you don't remember it, just go through 11th standard books to know what is mole concept. So if we take 1 mole of electrolyte and dissolve in certain amount of volume, then that volume of solution containing 1 mole of dissolved electrolyte is taken. We are going to understand about the significance of lambda. Now, suppose this solution containing 1 mole of dissolved electrolyte is taken in a vessel in which 2 electrodes are placed parallel to each other 1 centimeter apart from each other. Then, the electrical conductance exhibited by this solution is the molar conductivity. Understood? So we have taken 1 mole of dissolved electrolyte in certain amount of volume. We have taken it in a vessel where 2 electrodes 1 centimeter apart from each other placed parallel to each other. That vessel containing this solution and the electrical conductance now exhibited by this solution is the molar conductivity. In short, we can say the molar conductivity is the electrical conductance generated by all the ions in 1 mole of the electrolyte. Understood? So this is the significance of molar conductivity. Now, we will see the relation between conductivity and molar conductivity, that is K and lambda. We know what is K and we also know what is lambda. Now we will see the relationship between these two concepts or these two factors. Now, conductivity K, it is the electrical conductance of 1 cubic centimeter of solution. That means we have to take any solution and 1 cubic centimeter part of it, how much electrical conductance it shows, and that is K. Now, lambda. Suppose if V is the volume of solution in cubic centimeter, suppose we have taken V volume of the solution in cubic centimeter, it contains 1 mole of dissolved electrolyte. Then its electrical conductance will be lambda, because lambda is the electrical conductance of 1 mole of solution. So we have taken V mole of solution in cubic centimeter and 1 mole of electrolyte is dissolved in it, and then the conductance shown by this solution is lambda. Understood? K is conductance of 1 cubic centimeter and V is the conductance of 1 mole of solution. Now, each 1 cubic centimeter portion in the volume V as conductance K. Now we have taken V volume of the solution. Of this V volume, each 1 cubic centimeter portion has conductance K. Then, total conductance of V cubic centimeter will be K into V. It is but natural. We have to just multiply by K into V will be the total conductance. Now, this is molar conductivity. This is molar conductivity. Now, we have lambda equal to K into V. This is our equation. Now, we will add one more quantity, that is concentration. Concentration of solution, suppose it is equal to C, and concentration moles per liter, always it is measured like this, C moles per liter. Now, Kv is lambda equal to Kv is our equation. Now, this moles per liter, if we want to convert in cubic centimeter, then it is divided by 1000, and hence it will become C moles per liter divided by 1000 cubic centimeter per liter, and is will equal to be C upon 1000 moles per cubic centimeter. That is Cm raised to minus 3. Understood? Because we want to convert this per liter into cubic centimeter, because we have K, which is the electrical conductance of 1 cubic centimeter. So equate, and we want to find out the relation between K and lambda. That's why we have converted concentration terms in C upon 1000 moles per cubic centimeter. Now, for V volume V of the solution in cubic centimeter containing 1 mole of an electrolyte is a reciprocal of concentration always. V is equal to 1 upon concentration. Volume is always reciprocal of concentration. Hence, 1 upon concentration, substitute the value. It is, as we know, concentration is C upon 1000. Hence, V will be 1000 upon C. And the unit will also be reversed, that is Cm square per mole. Hence, we got the value of V, and we have equation 5.7 is lambda equal to K into V. Now substitute the value of V, and thus lambda will become now, K will remain as it is. Instead of V, we are going to take the value 1000 upon C. Hence lambda will become now 1000 into K divided by C. Lambda equal to 1000 K upon C, because our equation 5.7 is lambda equal to K into V. So this is what the relation between lambda and K, conductivity and molar conductivity. This is very important equation. So just go through it, write down all the steps to get that equation. And you will remember that. When you write each and everything, then it will become easier and it will be permanently noted in your mind. So better way, each and everything after reading, try to write it. Now, again, we are going to learn about variation of conductivity with concentration. How the conductivity changes with concentration. As well as we are going to learn about variation of molar conductivity with concentration as well. Now, the electrolytic conductivity is, again the definition we'll just learn. What is electrolytic conductivity? Is the electrical conductance of unit volume of solution. Electrolytic conductivity is the electrical conductance of unit volume, that is 1 cubic centimeter of solution, and it depends upon what? On number of current carrying ions present in that unit volume of solution. When we dilute this solution, total number of ions increase because there is increase in degree of dissociation. Last year we learned about degree of dissociation, that is alpha. As degree of dissociation increases, on dilution, total number of ions also increase. But this increase in total number of ions is not in proportion of dilution. Hence, the number of ions per unit volume, per cubic centimeter we can say, of solution decreases. Number of ions increases because volume increases. But that number of ions per unit volume, that doesn't increase, but it decreases, and hence there is a decrease in conductivity with decrease in concentration of solution. So concentration of solution decreases, the conductivity also decreases, and the reason behind it, as alpha or degree of dissociation increases, total number of ions increases on dilution, but per unit volume, number of ions will decrease. Hence, there is decrease in conductivity. What happens with molar conductivity? So, we'll learn about variation of molar conductivity with concentration. The molar conductivity is what? It is the electrical conductance of 1 mole of an electrolyte in a given volume of solution. When we say 1 mole, that means the number, everything is fixed. The increasing, on dilution what happens? The number of ions increase. The increasing number of ions produced in solution by 1 mole of electrolyte lead to increased molar conductivity. Normal conductivity decreases with the normal conductivity decrease with decrease in concentration. But on dilution, number of ions increases, and 1 mole, it has fixed number of ions. But when it increases, the number of ions increase, and hence there is increase in molar conductivity. So these two conductivities, they go opposite to each other. So up to this for this time, and after that we will learn further in the next session. You see, this chapter or this lesson is somewhat critical. So basically, last time also I told you, and this time also, that be with me every time. That part which has been taught to you should be practiced, should be learned again and again. by keeping textbook open in front of you. Okay, now the time for assignment. So assignment for today: define a molar conductivity and give relation between conductivity and molar conductivity. That means lambda will be 1000 K upon C. You have to write the derivation step by step. I haven't asked about significance of molar conductivity because that significance part has been deleted for this year. But I'm going to take all the deleted portion of this lesson. I'm only going to mention it that it has been deleted. But as all the lesson is for CET and the concepts are basic, hence I'm going to take or teach all the part of this lesson. But I will mention every time what part has been reduced. Like that, significance of molar conductivity is not for this year. Thank you.